today we are going to discuss about electricity. Yes, students, we already discussed what is electric current. Okay, therefore now we are going to discuss about electric circuit and its components. Okay, students, we already know what is electric current. What is electric current? Electric current is nothing but flow of electrons, right, or rate of flow of charges. That is electric current. Now we are going to discuss about what is electric circuit and the electric components. Okay, students, right, shall we go to the topic? Okay, right. First one is electric circuit, right? What is electric circuit? See, a closed path in which electric current can flow is called an electric circuit, right? A closed path in which electric current can flow is called an electric circuit. Yes, there are two types of electric circuit. One is open circuit, another one is closed circuit, right? So open circuit, no current flows. In open circuit, no current flows. In closed circuit, current flows continuously. See, this is open circuit and the circuit is open. Okay, and this is what? Sorry, this is the closed circuit and this is the open circuit. Okay, so this is small is this is the closed circuit and this is what? Open circuit, because the switch is open now, that's why this is open circuit, this is the closed circuit. Okay, students, so this is word is unfortunately interchanging. Okay, right, students? Okay, so in open circuit, no current flows. Closed circuit, current flows continuously. Okay, students, right. Electric circuit symbols, you should know these symbols. First one is an electric cell, so 1 plus and 1 minus. So the bigger line is positive and the small line is negative. A battery or combination of cells, so this is continuous, more than one cell is a battery or combination of cell, right? Okay, and then plug, key or switch, that is open. So this type of symbol explain the key or switch is open. If you go to the next one, if the dot present at the center, that is switch closed, that is plug, key or closed. Okay, students, right. And a wire joint, suppose the wire joint like this, and wire crossing without joining. See, is any there wire crossing without joining like this. An electric bulb like this, and the resistor of resistance like this. Variable resistance or rheostat like this. So these two symbols are explained that which one? Variable resistors. Next, ammeter like this. A means what? Ammeter, and here V means what? Voltmeter. This is positive and this is negative of the meter, and this is the positive and negative of the meter. So ammeter to measure the current and voltmeter to measure the voltage. Okay, students, right. Next, come to Ohm's law. So Ohm's law is very important. Okay, Ohm's law. What is Ohm's law? Yes, It was started by George Simon Ohm. Yes, see this picture. This is the picture of Simon Ohm, right? Yes, see this. It stated that at a constant physical conditions like temperature are kept constant, then the amount of current flowing through the conductor is directly proportional to the potential difference across its end. That means at constant temperature, the constant current flowing through the conductor is directly proportional to the potential difference across its end. That is I. I is directly proportional to V. I means current, V is potential difference voltage. Okay students, so if that is proportional here, when we are remove this one, we have to use some constant and equal. That constant is R. R is a constant, right? That means resistance. So what is Ohm's law? At constant temperature, the constant current or steady current flow through the conductor, it is directly proportional to the potential difference between two ends of the conductor. So students please underline this statement and the formula. So formula, what is Ohm's law formula? V is equal to IR, is equal to IR, right? R is a constant. So according to this law of conductors are divided into ohmic conductors and non-ohmic conductors. So based on this Ohm's law, there are two types of conductor classified. One is ohmic conductor, that is non-ohmic conductor. Ohmic conductor is nothing but it obeys the Ohm's law. That means follow the Ohm's law. A non-ohmic conductor does not follow the Ohm's law. That means does not obey the Ohm's law. Okay students, right? Now what is ohmic and non-ohmic? It's very simple. When we are increase the voltage, when we are, this is x-axis voltage and y-axis current. When we are increase the voltage, what is increase? Current also simultaneously increase. For example, 0.1 voltage increase, the current also 0.1 ampere. So when we are increase the voltage, the same amount of current will be increased. That is ohmic. V is directly proportional to I. Directly proportional means when you are increase any one side, the other side also what? Increased. But if non-ohmic conductor, not like that. See, when you are increase the voltage, there is no changes in current. See, this is current, this is voltage. For example, 0.1 voltage increased. What is the current? Zero current. But see this, after particular voltage only the diode should conduct the current. That's why it should like this. For example, 0.3 voltage increase, then only we will get 0.1 current. So ohmic and the non-ohmic conductor. You should know what is ohmic and non-ohmic. What is ohmic and non-ohmic? Ohmic means it obeys the Ohm's law. Non-ohmic means it does not obey the Ohm's law, right? Okay students, right? And then next, come to the book definition. See this, according to Ohm's law, at a constant temperature, the steady current flow through the conductor is directly proportional to the potential difference between ends of the conductor. That's why I is directly proportional to V. Then I divided by V is equal to constant. That constant is nothing but R. Okay students, so please underline this statement and the formula. Okay students, right? Okay, and now continuation. See, the value of this proportionality constant 1 by R, right? So I is equal to 1 by R into V. right? 1 by R into V, because if I am taking I this side, what will come? V go into this side. So the constant is nothing but 1 by R. That's why 1 by R into V. Okay, right? And next step, if this R go to that side, we will get IR. So V is equal to IR. R is a constant for a given material. R is a resistance. R is what? Resistance. So what is the formula for Ohm's law? V is equal to IR. V is equal to IR. Okay, students, please underline. Now, so in our book, this is a small relation given, potential difference circuit. See this, here x-axis voltage, y-axis current. See, when you are increase the voltage, current also increases, you will get straight line. See, for example, 5 voltage current, the 5 voltage applied, the current is increased 2.5 ampere. See, 10 voltage, the current increases 5.0, that is 5 ampere current. So when we increase the voltage, the current also increase. Yes, that means conductor. Okay, students, right? Okay, next, resistance and resistivity. So R means resistance, no? Yes, that's why we are going to discuss what is resistance and resistivity. First, resistance. It is defined as the torrents of flow of current, right? And it is the ratio of potential difference to current. R is equal to V by I, the ratio of potential difference to the current. That's why V by I. The SI in it is volt per ampere, but practically the unit is ohm, OHM. It is denoted by this symbol, ohm. Ohm means unit of resistance, right? Okay, next, the reciprocal SR resistance is called conductance. Reciprocal of its resistance is conductance. What is the unit? Ohm inverse. That means power minus 1. Ohm inverse, right? See, there are two circuit, high resistance low current, low resistance high current. So if it is used high resistance, what is the current flow? Low amount of current only flow. If you use a low resistance, high amount of current flow. That means it's nothing but, resistance is nothing but to block the flow of current. Okay, if any conductor has low resistance, it conduct maximum current. If a material having high resistance, it conduct minimum amount of current. Okay, students, right? Okay, resistance. Yes, an electron traveling through the wire and loads of external circuit encounters resistance. See, resistance is the hindrance of flow of charge. Hindrance of flow of charge. For an electron, the journey from terminal to terminal is not a direct route. It's not a direct route. Rather, it is a zigzag path, and that result from countless collisions with fixed atom within conducting material. So the electron encounter resistance and hindrance to their movement. The same one, this is brief explanation. You not worry about this one. Yes. This is another explanation, right? Now the SI unit of resistance is ohm. See, this is the component resistor. This is the resistor picture, right? Now see, continuation. Factors affecting the resistance. So resistance is to block the current flow, right? The SI unit is ohm, that is we know that. But some factors affecting resistance. The factors is R is directly proportional to length, and R is that inversely proportional to A. Inversely proportional to A. That means if you are increase the length, the resistance also increase. But if you are in when we are increase the area, the resistance will be decreases. That's why directly proportional and inversely proportional. So from first and third we can get R is directly proportional to 1 by A, and R, if we remove this directly proportional, you have to use some constant. That constant is nothing but rho. Therefore R is equal to rho S L by A. L by A, right? So rho is the specific resistance of the conductor. See, this is the area. When we are increase the area, the resistance will be decrease. When we are increase the length, the resistance also increase, right? That's why R is equal to rho L by A. Okay students, so two factors affecting what? Resistance. Okay, right. Now come to that resistivity material. Nowadays we are all using n type of material. No, it has resistance and resistivity in ohm meter. Yes, see the silver has resistivity 1.59 into 10 power minus 6, and see that copper has resistivity 1.68. In gold, aluminum, tungsten, iron, steel, platinum, lead, nichrome, coal, germanium, silicon, human skin, glass, rubber, sulfur, and quartz. So these are all materials. Okay, all the material has resistivity. Yes, based on the resistivity only they are selecting the material to make a home appliances or other electronic appliances. Okay students, right? Okay, measuring devices. So we discussed electric current and voltage. No, so what are the measuring devices? First one is ammeter. Yes, in circuit no ammeter symbol, please remember the symbol meter. So this ammeter, it measured one current flow. Yes, so to measure the amount of current, that is ammeter, right? Now but see this first point, it must be connected in series in the circuit. The ammeter is always connected series in the circuit, right? Okay, now positive side of the ammeter must be connected nearest to the positive terminal of the battery, or vice versa, right? See this ammeter, the ammeter positive is connected to positive of the cell, the negative is connected to negative through the bulbs like this. So this is the connection, right? So ammeter connected is always in series in the circuit, right? Next, voltmeter. Voltmeter is nothing but meter to measure the voltage or potential difference. See this voltmeter must be connected in parallel to the circuit. Now the voltmeter is always connected in parallel to the circuit. See, the positive side of the voltmeter is connected to the positive terminal of the cell and vice versa. Now see this voltmeter, the positive terminal is connected to positive, negative connected to negative. Yes, this is the circuit. See, this is the voltmeter, this is the battery. The positive is connected to positive. This is the parallel connection. Okay students, so ammeter to measure the which one amount of current in a circuit, voltmeter to measure the voltage. Okay students, right? Okay. Okay students, thank you students. Today class is over. We'll discuss on later and we'll see on next video. Okay students, thank you.